On the last Saturday of September 1944, American heavy bombers crossed the skies over northwestern Germany and turned the city of Bielefeld into a firestorm. When the fires finally burned themselves out days later, the old city center was gone. And among the wreckage along the railway corridor, a machine tool factory that had operated continuously for 74 years had ceased to exist. The factory belonged to a company called Gildemeister, and by any reasonable measure, the story should have ended right there, in the rubble of a bombed-out German industrial city in the final winter of the Second World War. But that is not what happened. What rose from that destruction became one of the most consequential machine tool enterprises in history. A company that would absorb two bankrupt rivals, fend off a Wall Street hedge fund, merge with a Japanese dynasty, and then find its own precision equipment inside Russian weapons factories while a war raged in Ukraine. This is the story of how a locksmith's workshop in a railway town became the backbone of modern manufacturing, and why the machines it built refused to stay out of the wrong hands. If you're new to Trade Archive, consider subscribing and hitting that like button. We cover the companies, machines, and founders that built the industrial world, and there is a lot more to come. To understand how Gildemeister began, you have to understand what Bielefeld was in the 1860s. It was a linen town, turning itself into something else. The textile mills still dominated, and in 1870, roughly 1 in 10 of all the mechanical looms in Germany ran inside its city limits. But the money and the energy were shifting into metal. A new generation of migrant craftsmen, most of them from outside Westphalia, were building workshops along the rail lines and transforming the city into an engineering cluster. The catalyst was the sewing machine. Around 1861, a workshop called Beer und Koch had opened on the edge of town, and among its roughly 14 employees were two men who would reshape Bielefeld's industrial future. One was Nicholas Duurkop, who would go on to found the Duurkopwerke and eventually build automobiles. The other was a locksmith from Leubsen in Pomerania named Friedrich Gildemeister. By the mid-1860s, Bielefeld's sewing machine makers were producing around 15,000 machines a year, exporting to Austria-Hungary, Scandinavia, Russia, and as far as Turkey. Duurkop left to co-found his own firm. Others splintered off into what became Koch's Adlerwerke and the Ankerwerke. But Friedrich Gildemeister looked at this ecosystem and made a different calculation. He did not want to build sewing machines. He wanted to build the machines that built them. On October 1, 1870, he established Werkzeugmaschinenfabrik Gildemeister und Comp directly beside the Köln-Minden railway station. The Hamm-Minden section of that rail line had opened in 1847, and by the time Gildemeister hung his sign, the station was a major freight hub on the northern edge of town, surrounded by flat industrial land. Heavy cast iron arrived by rail. Finished machines left by rail. The location was not an aesthetic choice. It was logistics. The early products were lathes and tooling, along with agricultural machinery. In an era when most German machine tools were still bespoke assemblies, hand-fitted by individual mechanics, Gildemeister pushed toward standardization, building from interchangeable components and repeatable assemblies. It was a radical bet in the 1870s Westphalia, where the craft tradition still valued the hand-fitted joint over the factory-produced part. Germany's machine tool industry was catching up fast. Around 1900, German builders overtook the English and French by roughly a generation in production technique. The Verein Deutscher Werkzeugmaschinenfabriken, the VDW, was founded on December 7, 1891, at the Castens Hotel in Hanover by 11 industrialists. Competitors like Pittler in Leipzig were patenting turret lathes for the bicycle boom, but Gildemeister was carving out a reputation for precision turning that would outlast all of them. By 1890, the company employed roughly 100 people. Among them were 3 technicians whose sole job was the intricate final assembly of the heavy machines, and a single wages clerk to manage the growing payroll. It was still a small operation, but it was no longer a workshop. In 1899, Gildemeister reorganized the partnership into a public limited company, an AKTIENGESELLSCHAFT, with capital assets of 1 million Goldmarks. Friedrich Gildemeister ran the firm for another 7 years before stepping away in 1906. Almost nothing is known about his personal life beyond the factory gates. No reliable public source confirms his birth year, his death year, or what became of him after retirement. One regional newspaper gives 1837 to 1915, but even that has never been independently verified. He is a founder who built something that outlived him and then disappeared into the silence that swallows most 19th century industrialists. What is certain is the man who replaced him. Wilhelm Berg was an engineer, and unlike Friedrich Gildemeister, he had been abroad. Berg had studied American series production methods firsthand, the same Ford-style philosophy of standardized, high-volume manufacturing that was transforming every industry it touched. He took control of Gildemeister in 1906 and immediately began cutting. By 1915, Berg had slashed the company's sprawling product catalog down to 4 focused lines: multi-spindle automatic lathes, drum turret lathes, longitudinal milling machines, and vertical and horizontal machining equipment. Fewer products, higher volume, more consistent quality. The old model of the German mechanical workshop that made a little of everything was finished at Gildemeister. Berg's most important contribution came in 1928, and it was technical rather than managerial. He patented a system for completely free chip fall, what the Germans call Freier Spanefall, combined with a new portal format automatic lathe design. In high-speed automatic turning, the metal chips cut from the workpiece have to clear themselves from the work zone instantly. If they jam, the machine stops. If they build up, they damage the part. Berg's patent solved this by redesigning the machine geometry so that gravity did the work, and in the same year, Gildemeister launched the POX, a multi-spindle automatic lathe that embodied the new principle. The POX allowed continuous, hands-free production runs that no competitor could match at the time, and it became the foundation of the company's reputation in high-volume turned parts for the next 2 decades. Then the First World War arrived, and everything bent. The Allied powers placed Gildemeister on a banned companies list after the armistice, restricting its ability to trade internationally. Berg responded the way an engineer would. He founded a parallel company, Berg & Co., initially registered under an agricultural machinery name to fit the post-war restrictions. By 1923, it was renamed Berg & Co. GmbH, and by 1925, with about 30 employees, it was manufacturing lathe chucks and clamping technology. That company still exists today as Bergspan-Technik. The man was not going to sit idle. The interwar years should have destroyed Gildemeister. The Great Depression gutted demand for capital equipment across Europe. Orders from domestic customers collapsed. But Berg had an unlikely client. The Soviet Union, desperate to industrialize under its 5-year plans, was buying machine tools from Germany in enormous quantities. The first plan, in force from October 1, 1928, prioritized heavy industry above all else, and the Soviets financed their imports through forced grain exports that starved millions. The moral dimensions of that trade were not part of the conversation in the 1930s Bielefeld. What mattered was that the orders kept coming. Gildemeister's workforce swelled to approximately 600 employees, sustained almost entirely by Soviet demand for the kind of precision turning equipment that Berg's POX and its derivatives could provide. Soviet output of cutting machines rose by a factor of roughly 25 from 1928 to 1937, and a significant portion of that early capacity was built on imported German iron. The machines Gildemeister shipped east in the early 1930s would train a generation of Soviet machinists and engineers in precision metalworking, skills that would later form the foundation of the Soviet defense industry's manufacturing capabilities. Germany was, in effect, equipping the industrial base of a future adversary. But in the depths of the Depression, with the alternative being bankruptcy, Berg shipped the lathes. By the late 1930s, Gildemeister was profitable, technically advanced, and deeply dependent on a single foreign client that was arming itself as fast as the machine tools could be shipped. When the Second World War began in September 1939, the factory was converted to armaments production by directive. Lathes that had been cutting parts for textile machines and agricultural equipment were now manufacturing artillery shells and munitions. The Soviet trade continued briefly under the Molotov-Ribbentrop Pact, but when Germany invaded the Soviet Union in June 1941, that lifeline was severed for good. Gildemeister was one of dozens of Bielefeld metalworking firms absorbed entirely into the Nazi war economy, alongside Duerkop, Koch-Sadler, Anker-Werke, and Benteler. The labor to run these factories came from forced conscription. After Fritz Sauckel's appointment as plenipotentiary for labor deployment in March 1942, foreign workers were shipped into German industrial cities by the hundreds of thousands. Across Bielefeld, more than 14,000 forced laborers were deployed over the course of the war, the majority from the Soviet Union and Poland. Duerkop alone used up to 3,000, housed in camps on the Johannesburg. Gildemeister used at least 280, documented in the Bielefeld city archives under the Nazi euphemism Fremdarbeiter. They wore discriminatory OST patches on their clothing, worked 12-hour rotating shifts, were barred from air raid shelters during bombing attacks, and lived under the constant threat of deportation to concentration camps if they failed to meet production quotas. Most were repatriated in 1945, and many of those returning to the Soviet Union faced suspicion, interrogation, and in some cases, further punishment from their own government for having been captured or taken by the Germans in the first place. Decades later, in 2000, Gildemeister became one of approximately 6,500 German companies that contributed to the Stiftung's initiative Der Deutschen Wirtschaft. The fund eventually paid out roughly 4.4 billion euros to 1.66 million. Surviving former forced laborers across 98 countries. And then came September 30th, 1944. It was a Saturday, the day before Erntedank, Harvest Thanksgiving. The skies over Bielefeld were brilliant and clear. A 13-year-old boy named Heinz Kirchhoff, standing at the Gerenberg Hill, watched the American bomber formations approaching and later recalled that in the beautiful weather, the planes were an imposing sight. The pre-alarm sounded at 12:57 in the afternoon. The full air raid alarm followed at 1:49 in the afternoon. Many residents, dulled by weeks of false warnings, barely moved. Then a voice broke through on the radio. "Attention! Highest alarm level. Enemy bomber formations on direct approach to Bielefeld. They have opened their bomb bays." The raid lasted roughly 30 minutes. It came in waves. First, heavy, high-explosive bombs that blew apart buildings and infrastructure. Then, blast bombs weighing up to 2,000 pounds that stripped roofs across entire neighborhoods. Then, thousands of incendiary canisters that turned the exposed timber framing into fuel. The fires merged into a firestorm that burned for 4 days. The primary targets, according to U.S. mission records, were the Bielefeld marshalling yard and a nearby ordnance depot. The force consisted of 266 B-17s of the 3rd Bomb Division, escorted by roughly 240 P-47 Thunderbolts and P-51 Mustangs. Allied sources described near-total cloud cover over much of western Germany that day, but Bielefeld itself lay under clear skies, and the bombing was visual rather than radar-directed. Gildemeister's production facilities were not the bullseye, they were collateral. The distinction made no difference to the machines. The factory was annihilated. Bielefeld's total air war death toll would eventually reach 1,349, with more than 15,000 dwellings damaged or destroyed. The city was taken by American troops on April 4, 1945. In 1945, the Allies placed whatever remained of the company on the dismantling list, earmarked for reparations under the Potsdam Agreement. The program was eventually wound down by 1950, having reduced West German industrial capacity by only a small fraction. But in the spring of 1945, Gildemeister was a name on a list of companies slated for liquidation. Karl Bernhard Grauthoff refused to accept that. Born in 1906, Grauthoff was Wilhelm Berg's son-in-law and had deep roots in both Gildemeister and Berg & Co. He knew how the machines worked, how they were sold, and who the customers were. He assumed control in 1947, and the reconstruction that followed was brutal in its simplicity. 25 employees, no factory, no machines. Just rubble, a name, and the knowledge of how to build lathes. But Grauthoff had something else. He had timing. Germany's post-war economic recovery, the Wirtschaftswunder, became one of the most extraordinary industrial reconstructions in modern history. Factories across Western Germany were rebuilding simultaneously, and every one of them needed machine tools. The demand was not just domestic. Marshall Plan dollars were flowing into European reconstruction, and the machine tool builders who could deliver precision equipment fast enough were writing their own futures. Gildemeister went public again in 1950, raising the capital needed to rebuild properly. The products that followed were not tentative. The RV50 turret lathe arrived first, then multi-spindle automatic bar machines, then the first 8-spindle automatic chuck lathe. Each one was an evolution of the pre-war designs that Berg had perfected, updated for the post-war era's higher production volumes and tighter tolerances. The automotive industry was the largest single customer segment. Every crankshaft, every valve stem, every transmission gear needed turning, and the manufacturers building cars for a continent that had barely owned them before the war needed equipment to do it at scale. By 1961, Gildemeister had outgrown its rebuilt facilities entirely. The company purchased a 300,000 square meter plot in the Sennestadt district outside Bielefeld. Construction of a modern industrial campus began in 1964, with assembly halls, test bays, and administrative offices laid out on a scale that would have been unrecognizable to Friedrich Gildemeister. In 1965, Gildemeister developed the RSA, its first numerically controlled lathe, which reached the market in 1967. The RSA was the bridge between the mechanical automation that Berg had pioneered and the digital future that was coming. Punched tape told the machine where to move, how fast to cut, and when to change tools. The machinist's hands were no longer on the hand wheels. They were loading programs. Over the following decade, production migrated building by building to Sennestadt. By 1976, the old factory beside the railway station was abandoned for good. The site sat empty for over a decade before Bielefeld chose it for its new Congress Center. Today, the Stadthalle, a white sweeping structure designed by Gerkan, Marg und Partner, and opened in August 1990, stands on the ground where Friedrich Gildemeister once assembled his first lathes. There is no plaque. The expansion was not only geographical. Gildemeister went on an acquisition campaign that reshaped the northern German machine tool landscape. In 1970, they acquired Heidenreich and Harbeck, a historic Hamburg manufacturer whose VDF-branded lathes were a fixture in workshops across Europe. The acquisition brought something Gildemeister did not yet have: genuine expertise in CNC-controlled turning. 2 years later came Max Müller-Brinker near Hanover, and in Italy, the company took control of export operations that evolved into Gildemeister Italiana, absorbing brands like Graziano of Tortona and cementing the company's supremacy in multi-spindle automatic lathes for high-volume production. The mid-1970s brought the company to the edge of a technological revolution that would redefine the entire industry. Gildemeister introduced the Electro-Pilot M, an electronic control system for machine tools that the company marketed as a world first. Whether or not that claim holds up to strict scrutiny, the direction was unmistakable. By 1977, genuinely microprocessor-controlled multi-spindle automatics were rolling off the Sennestadt line. These were machines that could execute complex turning sequences, tool changes, and positioning commands without continuous human intervention. The gap between a skilled machinist hand cranking a turret and a computer executing G-code in milliseconds was closing fast, and Gildemeister was determined to be on the digital side of that divide. The electronics business grew large enough to spin into its own division, Gildemeister Automation, by 1982. But the real transformation was still ahead, and it came not from internal innovation, but from the collapse of two legendary rivals. In the early 1990s, a severe global recession gutted the machine tool sector. Orders evaporated across Europe. Factories that had run 3 shifts sat idle. Deckel and Maho, two of southern Germany's proudest names in precision milling, attempted to save themselves by merging in 1993 to form Deckel Maho AG. The logic was sound on paper: combined sales forces, consolidated production, shared engineering resources, but the merger did not generate enough momentum to overcome the debt load and collapsing order books. In 1994, Deckel Maho AG declared bankruptcy. The insolvency was not a quiet corporate restructuring. It was a traumatic event for Germany's industrial identity. Thousands of highly skilled machinists and engineers faced the loss of their livelihoods. Union leaders fought desperate rearguard actions. The trade press covered it as a national disgrace. Gildemeister saw something else entirely: an opportunity that might never come again. The company acquired the bankrupt assets from the receivers and renamed itself Deckel Maho Gildemeister AG. The acronym DMG entered the lexicon of global manufacturing overnight. The strategic logic was elegant and ruthless. Gildemeister was, at its core, a turning company. Its DNA was in lathes. Deckel and Maho were milling companies. Their DNA was in spindles and 5-axis kinematics. By absorbing both, DMG could offer a complete machining portfolio, turning, milling, and everything in between, under one corporate roof. No customer would need to shop elsewhere. Among the inherited assets was the Seebach factory in Thuringia, founded in 1862 by the Thiel brothers for clock fittings and evolved over more than a century into a specialist machine tool plant. Under DMG, Seebach became the development center for 5-axis simultaneous milling, and the machine it produced became arguably the most important product in the company's history. The DMU-50, a universal 5-axis milling machine compact enough for a mid-sized workshop, but precise enough to cut aerospace-grade titanium alloys in a single setup. The Seebach plant has assembly capacity for up to 2,000 machines per year, and tens of thousands of DMU-50 units have been installed in factories worldwide. Aerospace contractors use them to cut turbine impellers. Medical device companies use them to mill prosthetic joints from cobalt chrome alloys. Die and mold shops use them for the complex 3-dimensional surfaces that shape everything from car bumpers to smartphone casings. DMG MORI still markets it as their best-selling 5-axis model. Beyond the DMU series, the combined company developed product lines that pushed the boundaries of what a machine tool could do. The CTX and NTX turn mill platforms allowed raw bar stock to be turned, milled, drilled, and finished as a complete part without ever leaving the machine. A component that once required 3 separate machines and 2 manual setups could now be produced in one clamping, with tolerances measured in microns. The ultrasonic series, derived from technology acquired through Sauer GmbH in 2001, induced micro-vibrations into the cutting tool to machine materials that would shatter under conventional machining, optical glass, technical ceramics, silicon carbide. And the Lasertech line merged subtractive milling with additive metal printing, allowing engineers to build internal cooling channels in turbine blades that no drill bit could ever reach. By 2016, more than 500 Lasertech machines had been installed worldwide. DMG had become a machine tool empire, but it was still fundamentally a European one, and in the 21st century, with customers in every industrial country on Earth that left half the world underserved. The partnership with MORI Seiki began in March 2009, born partly from the wreckage of the global financial crisis. The collaboration started with joint sales operations in Taiwan, Thailand, and Turkey, then expanded rapidly across Asia and the Americas. By 2011, the two companies shared a joint presence at EMO Hanover, the world's largest machine tool trade fair. In 2013, the company became DMG MORI Seiki AG. And in 2015, the Japanese parent completed the acquisition of a controlling stake, crossing the 52% threshold that German corporate law required for consolidation. The deal did not go smoothly. Paul Singer's Elliott Management, one of Wall Street's most aggressive activist hedge funds, built a stake in the German company, reaching 10.1% by April 2015. Contrary to the squeeze-out narrative that sometimes circulates, Elliott told Reuters it was backing the Japanese strategy as a long-term investor while positioning itself to prevent MORI Seiki from extracting value on the cheap. The effect was the same, regardless of intent. The Japanese parent had to pay a premium to buy out Elliott's position over the following years. On June 8, 2015, the company officially became DMG MORI AKTIENGESELLSCHAFT. By 2016, a domination and profit transfer agreement was in place, and the integration was functionally complete. The combined entity operated under the banner Global One Company. By fiscal year 2024, DMG MORI AG reported sales revenues of €2.228 billion and a workforce of 7,498 employees. The global enterprise employed more than 13,500 people across 17 production plants and 124 sales and service locations in 44 countries. The machines bearing the DMG MORI name were, by any technical measure, among the most sophisticated manufacturing equipment on Earth. And that was precisely the problem. A 5-axis CNC milling machine does not know what it is cutting. The same spindle that mills a titanium hip implant at a medical device company in Switzerland can mill the impeller for a cruise missile engine at a defense plant in central Russia. The same turning center that produces automotive transmission shafts in Stuttgart can produce artillery shell casings in Ulyanovsk. These machines are classified as dual-use technology under international export control regimes, governed by the Wassenaar Arrangement and enforced through national licensing. In the language of sanctions law, they are strategic goods. And for decades, Western governments have understood that access to high-precision machine tools is one of the most reliable indicators of a nation's ability to manufacture advanced weapons. DMG MORI had opened an ultra-modern production facility in Ulyanovsk, Russia, around 2015, producing machines from its Ecoline range. When Russia launched its full-scale invasion of Ukraine in February 2022, DMG MORI announced it was halting all operations in the country. The reality, according to multiple investigations, was far more complicated. Redaktionsnetzwerk Deutschland published findings in 2023 based on customs documents showing that DMG MORI machines, components, and replacement parts had continued flowing into Russia through intermediaries in Turkey and elsewhere. A Moscow arbitration court ruling in July 2023 established that DMG MORI Rus, the company's Russian subsidiary, had supplied machine tool components to Saturn Instrument Plant, a subsidiary of the military aircraft engine manufacturer UEC Saturn, as late as August 2022, months after the invasion began. On September 20, 2023, Ukraine's National Agency on Corruption Prevention added DMG MORI to its official list of international sponsors of war. The designation stated that the machines of these companies continued to be purchased by Russia despite sanctions, and that without them, Russia could not manufacture weapons at the scale required to sustain its war effort. DMG MORI's own internal investigation revealed that local Russian employees had sold 122 machines from the Ulyanovsk plant without the knowledge of authorized management. The company maintained it had fully complied with all applicable sanctions regulations. No German criminal conviction has been reported. On February 19, 2024, Vladimir Putin signed a decree transferring 100% of Ulyanovsk machine tool plant to Rosimuzhchestvo, the Russian Federal Property Management Agency. The plant was seized outright. DMG MORI recorded a loss of €91.9 million from discontinued operations and later received approximately €101.9 million through a German investment guarantee claim. The Ecoline range was discontinued entirely. Gildemeister began as a locksmith's workshop beside a railway station. It survived unification, 2 world wars, Allied bombing, Allied dismantlement orders, industry-wide recessions, hostile corporate raids, and geopolitical scandal. The machines it designed and built cut the metal that holds together jet engines, artificial knees, semiconductor housings, and automobile transmissions on 6 continents. The company's name has changed 4 times since Friedrich Gildemeister first hung his sign in 1870, but the machines never stopped running. If this is the kind of story you want more of, Trade Archive has an entire library waiting. Hit subscribe, and we will see you on the next one.